Hello everyone, welcome to my YouTube channel. Today I am going to discuss about buckling analysis with the help of Etabs. Generally, we should know that what is buckling. See, buckling is generally provided to check the stability of the structure. Okay, and it is not necessary that each and every structures you have to consider the buckling analysis. There are some criteria. If that structures fulfill that criteria, then we generally apply the buckling analysis when we perform the analysis and design of the structure. So what are the criteria? The criteria is if the ratio of the height of the structures to the least lateral dimension of the structure is greater than 4. So in that case you have to consider the buckling analysis in your analysis and design. Okay, suppose that this structure's total height of the structure is just we see, we go for the top level and apply, then the height of the structure is here 74 meter. Okay, so 74 into 1000 we have to bring in mm, so you have to multiply meter to 1000, then it will come in mm. So 74 into 1000 divided by least lateral dimensions of the structures. Least lateral dimensions means from here to here this is x-axis, and from here to here this is y-axis. So already with the help of plan already we are seeing that the minimum distance will be this side. Okay, so 74 into 1000 divided by this distance. If this ratio is getting more than 4, so in that conditions you have to apply the buckling analysis in analysis of the structure and design of the structure. Okay, so and buckling analysis is generally consider or perform to check the stability of the structure, means structure will be stable or not. So what are the process we generally perform? Let us check. Okay, so firstly to apply the buckling we have to go in define. First just go to the define, and in define you have to go in load cases. Just go to the load cases, and here already see buckling is here, just you delete here. Okay, and we'll perform new one. Now just go here, add new case, just click here, and here in load case name just click buckling, just write buckling. Okay, and load case type just click here, see this is buckling, and here this is load type, load name and scale factor. So just click here, add and add. In first it will be dead load, scale factor as usual 1 will be there, and here instead of dead load just go to the live load, and here it will be same 1. Okay, and now just check number of buckling modes. So in buckling generally we provide the 6 modes, so here already 6 modes, and use preset p delta setting. Just click here and check it is okay not. So see here we apply the 1.5 times dead load, that is governing. Okay, because in the case of p delta there are two options. First one is that either 1.5 times dead load or 1.2 times dead load plus 1.2 times live load if the structure is below 50 meter. In between which one is governing you have to consider. So in this structures 1.5 times dead load is governing, so we are taking this one. Just check it is there or not. Okay, so it is here, just click and just go to the OK. Okay, after that just click here OK, and just run the analysis. Okay, just go here and run the analysis. It's running, it will be taking some times to running. Okay, we start the analysis run. Okay, so generally buckling analysis when you open the code to say there are some combinations also. Okay, so buckling analysis what we do is that we generally go to perform or to check the stability of the structure, either your structure is stable or not. So only we generally perform the buckling analysis. Okay, so just run the analysis, it's already under process. Let us see. After that, what you will do, just is taking, see here already is showing, okay, case 45% buckling has been completed, and here analyzing is 46%, and here also you can see that here already it's showing, it's means second by second it will be increased. Okay, so in that case you will get the idea that your buckling is under process note. Suppose that if, see, there is case 45%, maybe it takes more than 5 to 10 minutes. So what happen is that, means there are some problem in your model. Okay, suppose that it's taking more than 10 to 15 minutes to run the analysis. So just don't wait till 10 to 15 minutes. Just cancel with the help of this here and go to check the modeling in 3D, because sometimes what happen is that there are some other joints will create, and due to that operation process will not perform. So either being a structural engineer, you have to open your four eyes. Okay, first two eyes is for visual and other two eyes to think about that. And always when you start for the analysis or design of the structure, you have to go for the PBD design, means performance based design, means what structures need. Don't think like how it will build, just think what structures need. So if you will understand that process, what structures need, then it is very easy for you or easy for us to think that. So always when you perform any types of structures, just you go for the PBD, performance based design, because it is very good process to think or to perform the structures. Okay, so see, it's taking some time, but not more than 5 minutes. So just we say maybe it will perform, neither will go to check either there are some problem in the analysis or not. Okay, just see, it's already come, 45% is there. We'll see, neither what we'll do is that, see, already it's going, because already 52% is completed, means it is under process, means it's increasing, means like analyzing is under process, means there is no any problem in your modeling. But suppose 45% for 40%, then after it's not increasing 5 to 10 minutes, that time you have to cancel your analyzing process and go back and check in modeling what's the problem in modeling, because many times these things happen. Okay, so 59% is completed. Now we'll see that after that, when analysis will complete, then again what you have to do, you have to go in display, and in display you will get the table in scale factor of the buckling. You have to choose that one, and again that scale factor you have to again put to the scale factor in dead and live load, because already you know before in dead load scale factor we have been taken 1, and live load scale factor we have been taken 1. But when analysis will be completed, then again you will get new scale factor of the buckling. So that new scale factor you have to replace to the before one, and again you have to perform the analysis. And when you perform the analysis, then you will get 6 scale factors, and then again you have to make the envelopes, and then you have to perform. Just we'll see. Okay, just I have been resume the things what we are going to do. See, 86% has been completed, only 14% left. So we'll have to wait only 97% completed buckling. See, almost it's done. Okay, so we'll see what happened. See, completed. Now we'll see. Just see, here you have to see, because it is refreshing, already completed. Okay, now what you have to do, just go to the display, just click here and go to the show table, and you have to go to the structure output, then other output items, just click here, and here buckling factors, just click and OK. See, there are scale factors, new scale factors you have been taken. Okay, so what you have to do, there are six scale factor, but usually we have to consider first one. Okay, just you consider 8.91 only. Okay, so just remember, first buckling scale factor is 8.91. Just go, done. Now again go to the define, go to the load cases, and here see here buckling, just go to the modify, and instead of this scale factor, how much you received, 8.491 scale factor. Okay, so in both cases 8.491. okay, and just click, because see there are six scale factor, but only you have to consider one, only you have to consider one, that is 8.491, 8.491, because when we will consider first, it will be automatically, it will be adjusted. Okay, there is no need to take all six. First scale factor you have to take 8.4191, that is dead load and live load, and just click OK. Now again go to the OK, and again OK, and again run the analysis. Okay, now after that you will be getting six scale factors, six mode. That mode you have to again perform the envelope. This is the main things, because this is very main things, you have to create the envelope. Because what is envelope? Envelope is generally, the means of envelope is superimposed effect. You know well what is superimposed effect. So some persons, what happen is that, because many times I have been seen, they forgot to put the envelopes. So this is very big problem. If you forgot to put the envelope, then it will means your analysis will not perform better. So it is very necessary to put the value of envelope. And how we'll put, we'll see. Already 45% has been completed. Being a structural engineer, you have to keep some patience also. Okay, because when you do the job in your company, so sometimes you will have to face very too much pressures. Same day you have to complete it, and you have to submit your projects. So just you have to keep patience in that. Like that, suppose you see it's under process of analyzing, so you have to keep your patience and just watch how much has been completed, like that. Okay, see already 45% buckling has been completed, 55% has been left. So still what we have been seen, like that we have been seen that we have to go for the define load cases, and there you have to put buckling, and scale factor will be initially dead load scale factor is 1, live load scale factor is 1, and just run the analysis. After running analysis, you will get 6 scale factor value, but you have to choose only mode 1 scale factor value, and that scale factor value you have to replace to the dead load scale factor value and live load scale factor value, and just again run the analysis. It's running. After that, what we'll do, we'll see there are some criteria, so maybe it will take time, because it is the second step of buckling. Buckling is very compulsory. Okay, when structures needs buckling, and if you will not perform, then the life of the structure will not more. Buckling means that Giving a normal example, suppose a 70 years and 80 years old person is there, and you will tell them or tell him to stand 2 and 3 hours continuously. So after 20-25 minutes, 30 minutes, okay, he will not able to stand, because his legs will buckle like that. Okay, so this is called buckling. So like that, in structures also we check the stability of the structures. So this is called buckling. This is very good example of buckling. So same thing in structures also we perform the same things. We check the stability of the structure, and when we perform the buckling, we generally apply the buckling in design also. And buckling we generally apply in strength model. When you start to the creating the model, firstly we create the uncracked model. In uncracked model we check the model analysis, means behavior of the structure. Then we generally check the creep analysis, means deflections. After that we generally create the next model, that is service model. So in service model we generally check the maximum inter-story drift ratio due to the earthquake load. So that limit is 0.004, we know well. Then also we check the maximum story displacement due to earthquake load or due to wind load. So due to earthquake load, the formula is capital H, that is height of the structure, divided by 250. So this is the limit. And due to the wind load, that is H by 500. So we generally check, and when it is okay, then in service model also we generally check the vibration analysis if structure need. After service model we generally create the strength model, and in strength model we generally check the buckling analysis, we generally check the torsional irregularity, we check the soft story, we check the gust factor, etc. Okay, so buckling analysis we generally, suppose in interview also they can ask the questions, in which model you generally performed, we generally check the buckling analysis. So you have to say that in strength model we generally check. Okay, so already it has been completed. Now what we'll do that, let us see. See, it's completed. Now you have to go to the define and load combinations. Okay, in load combinations you have to go to the add new, and here just write what, buckling analysis, and here instead of linear add, here you have to put the envelope. It is very very important. Okay, so it's completed. Before that what you have to do is that, see, when you perform analysis, just go to the display. Okay, and go to the show table, and here just perform OK. See, here you will get the new buckling factor. Again I am telling that when analysis has been completed, you have to go to the display, go to the show table. Okay, and click OK. See, this is your new buckling factor. This new buckling factor if you have to create in envelope, this is very necessary. So just go to the file, go to the export current table, and to Excel just export here. It will automatically export. See, already exported. See, here it's already exported. Just remember this value. Okay, now just remember this value. Okay, now you have to go to the define, go to the load cases, and here it is already done, so no need, just go to the add new, and here just click buckling 1, and here instead of load case type click 1 minute, there are some problem, just go to the define, go to the load combinations, okay, and here click add new combo, and here buckling 1, and combinations type is here envelope. It is very necessary, don't forget to do this, okay, because some people what happen that they don't provide envelope, so it is very necessary, because envelope means that it is a superimposed effect. Now here we have to put that value, just click how much, how many, see this is 6 mode, okay, so just add 2 3 4 5 6, and just click here and provide here buckling combination, buckling, here also buckling like that, just click here buckling, and here also buckling, okay, and this is mode 1, this is mode 2, like that, this is mode 3, and this is mode 4, this is mode 5, and this is mode 6. And what are the scale factor of mode 1? See in Excel. First one is 1.049, so just 1.049. Second one how much? It is 1.169, so 1.169, and third one is 1.228, so third one is 1.228, and fourth one is how much? 1.26, so 1.26, and fifth one is 1.287, so 1.287, and sixth one is 1.338, so 1.338. It's already completed, just okay, here completed, just okay, and now go to the define load combinations, and instead of, what happen is that when you go to, so when you perform the designing, what happen is that, so instead of dead load, see here dead load is, see already it's provided, so in load combinations what happen, what you have to do, that instead of a dead load, where dead load and live load, so there you have to provide the what, buckling 1.5 times buckling. Suppose that there is a 1 point, see here here is a 1.5 times dead load plus live load, okay, so here you have to apply the 1.5 times buckling, because already I have been provided, so it's getting like, okay, already I have been provided, so it's showing like this, okay, just click here, go to the modify, and see here already, suppose that it is not, in case, now what will happen, see now when you perform the design, you have to go to the load combinations, and instead of where dead load and live load, there you have to add 1.5, suppose dead load is 1.5, so there also you have to apply the buckling. Suppose just click here and go to the modify, and see here dead load is 1.5, live load is 1.5, so again click and go to the buckling, okay, and here how much dead load is 1.5, so here create 1.5, and just okay and okay, and now just start the designing process. So this is the process to apply the buckling. I hope you understood. If there is any problem to understand, kindly DM me. I will try to resume the topic again. Okay. If you like my channel, kindly share and subscribe. I will be very thankful to you. Thank you so much.